Okay, so now let's talk about finding the area by limit definition. So we use a similar example that y equals x squared on the domain from 0 to 1 instead of 0 to 2, okay, for our convenience. So we just look at the interval from 0 to 1. Okay, so the idea is let's divide our interval 0, 1, 0 to 1 into n subintervals. With equal length. Okay, so we divide this one from 0 to 1 into n intervals. So total length is 1. So if you have the same, you divide it in evenly into n parts. So each part, which is the length is 1 minus 0 divided by n, right? So this is the 1 over n. So if we denote this is the x naught, this is the x1, so this would be 1 over n, x2, 2 over n, right? If you continue, this is the xi minus 1, this is the x sub I, this is the xn, right? Which is equal to 1, and this is the n, x sub n minus 1. So we can see that x1 equals 1 over n, x2 equals 2 over n. So you can guess xn I sub I is equal to I over n, right? And xn equals n over n, which is equal to 1, which is the same as this number. So our guessing for xi equals xi equals I over n is correct. Okay, so for our convenience, we use the right sum. Of course, you can use the left sum. Okay, we use the right sum. That means for each interval, we use the right endpoint as our height. Okay, we use the f values at this point for the first interval. For the second interval, we use the right endpoint on this interval, and we use for this interval we use this right endpoint as our height, f values at right endpoint, and for this the last interval we use this point as our height. So this is the ith interval. So the summation, which is the base times the ith interval, we use xi as our height, f of xi as our height. So this is the area of the ith rectangle. Okay, then we sum up I from 1 to n. We have n rectangles, right? We add them up. So which is equal to sum I from 1 to n xr at delta x, which is the base is 1 over n, right? xi we just find, which is this one, I over n. So this would be the f of I over n. Okay, so we do the calculation. So this is the summation I from 1 to n of 1 over n times f of I over n. F of x equals x squared. So this would be I over n squared. Okay, so now let's simplify a little bit. So this is the summation about I. I is changing, n is a constant, right? So this one, this is spread square out, which would be n squared, so you have n cubed, right? Times I squared. So if we take this as a constant, we can take out, right? So this is the n cubed I from 1 to n of I squared. So do you remember the formula for the summation, this is here is n, for I squared, which is 1 over n cubed, so which is 6. The denominator is 6. The numerator is n times n plus 1 times 2n plus 1. If you expand out, it would be 6n cubed. This would, the top would be 2n cubed plus 3n squared plus n. Okay, so this is the approximation with n subintervals. And we know if we let n, the number of the subintervals approaches infinity, then we will get the exact area, right? Last part we talk about this one. So the exact area, which is equal to, not approximately equal to, it's equal to the limit n approaches infinity of what? Of the summation I from 1 sigma I from 1 to n of delta x times f of xi. This is the limit of the right sum. Okay, so we just do the calculation for this sum, which is the limit n approaches infinity of 2n cubed plus 3n squared plus n over 6n cubed. So what is the limit? So how do we find this limit? This is the rational function, right? We find the highest power of the denominator, which is n cubed. So we divide by n cubed for each term. So this would be 6. This would be 2 plus 3 over n plus 1 over n squared, right? When n approaches infinity, so you can, if you are not familiar with that, you can look at the topics about the limit at infinity. So this would approach 0. This would approach 0. So you will have 2 over 6, which is 1/3. So this is the area, exact area between the curve, which is this one. Right, this is 1, 0, and this yellow area. This is the y equals x squared. Right, this is the yellow area, which is 1/3.